Hi, everyone. Today, what we're going to do is we're just going to basically spend the day doing some operations. And so you can see the title at the top of the screen. Today, we're going to go through and we're just going to multiply and divide some rational expressions. So on the screen, I want to tell you that we're not going to do anything more than multiplying or dividing some fractions today, even though it may start to look a little different as we progress. So what I would like you to do is just as fast as possible, work your way through 1A and then stop there, okay? So write down what question 1A is. We're following the instruction to simplify. I want a full solution to 1A. Pause it now. Okay, we're back. So I'm hoping that we tackled this without a calculator. We should have been able to. However, I'm really hoping that even though we understand that to multiply fractions means that we multiply straight across, that we are not actually doing that. That if we recognize that the green is the process for us to multiply fractions, then really what we end up getting in the green is a little bedmass question again. And in fact, notice that's pretty much what we did when we simplified rational expressions. That I'm hoping that very few of you actually calculated 8 times 9 and then calculated 15 times 12. So 10 15s is 150, 2 15s is 30, that's 180, and then had to spend time trying to reduce that fraction. But rather, if we recognize the bedmass situation, then really what we should have been doing was looking to divide out common factors wherever we see them. So I'm hoping that most people were reminded that since we're multiplying fractions, all we have in that original expression is multiply and divide. I can divide out common factors right now. And maybe we looked at that second fraction and we said, hey, a 3 goes into both top and bottom. But we also were reminded that we can cross-reduce. And I can take a 4 out of an 8, and I can also take a 4 out of a 4. And I can do the same thing and take a 3 out of a 3 and a 3 out of a 15. And really what I end up having then in that problem is I can multiply my top, which is a 2 times 1, and I can multiply my bottoms, which is a 5 times 1, and that we came into a 2/5. Now, I really hope that we went straight to a 2/5, and as I said, we didn't create a 72 over 180 and then reduce that. Like, great if we looked in top and bottom and said, hey, 36 goes into both those numbers. But I would bet that maybe it took us a little bit to reduce that fraction. So I think that I'm going to have a bunch of people who were reminded about cross-reducing after seeing A, and I'd like to give you another shot at it. So what I'd like you to do is to get down problem B, and then I want you to go start to finish, give me a fully simplified expression. Okay, pause it now. Okay, we're back. So for us to work our way through, I don't know how you see it. Like, do you look and see that a 5 goes into both 40 and 15? I could divide a 5 out. And then maybe I look and I say, hey, I've got an 8 that goes in 8 and 24. But I need to be very conscious. I know that nobody is trying to divide out a 3 from both of those because there is no division operation between them. That all I can do is to get down to that point of which I'm simplified, and I'm going to end up getting 1 times 8 over 3 times 3. Now, some of you will notice that you didn't cross-reduce the same way I cross-reduced, but we get down to the same thing because all we're doing is dividing out common factors. Okay, we take a look at C, and we just notice that now I'm just asking you to divide. I'm hoping that everybody understands that we can't try to divide out common factors right now because I have that division operation in between. However, we know how to divide fractions. That means that we flip and multiply, or we multiply by the reciprocal. That if I can just change my division problem into a multiplication problem, now I've turned it into one like the previous two, we're good to go. Okay, you finish that one off. Pause it now. Okay, we're back. Maybe the 8 and the 16 jump out at us. We can divide those out. We look at 15 and 21, and we notice we can divide out a 3 from both of those. And when we reduce that, we are coming in on 7/10. There we go. Okay, hopefully not too bad. We've been reminded a little bit about dividing out common factors, and our focus is going to be cross-reducing as much as we can. Okay, let's jump into some stuff that we're going to deal with today. What you'll notice in problem 2 is that's going to start to look like the normal sorts of problems that we're going to address. So what I would like you to do is to work your way through 2A. So copy that question down and then get a full simplified solution. Okay, pause it now. Okay, we're back. So my suggestion to you sometimes, and I'm going to really mark up my problem here, but my suggestion to you is I think it can be tough to go like, okay, so a 5 divides into a 5, and then, okay, so then I can divide out a 4 from both of those, and then I've got B's here, and then I've got, and all of a sudden, it can get so confusing with all these slash marks in your original expression that my recommendation to you, reduce your coefficients. That is, treat this problem exactly as we did and imagine that there were no variables. So I could divide out a 5 from 5 and 15. I could then divide out a 4 from 8 and 12. I can then divide out a 3 from both those 3's. All my coefficients have been reduced. My recommendation to you is put in one middle line. Multiply your fractions now. Notice we're going to have a 1 times 1 on top as my coefficient, but then I'll have an a squared times a and a b times b. On the bottom, I have my 2b squared. And just by putting that one line in, I think your risk for mistake is gone. That we should be good now to see that our b squareds are going to divide out, and that's going to reduce to an a cubed over 2. Nice. And so we know that we're all done. No, and I'm hoping that we can remember back to last time that we have to deal with our restrictions. So we look back to the first factored form. There's where everything is factored. Tops and bottoms are all one term. And I notice that the only restriction that I need to tack on is that b cannot equal 0 for all of those expressions to be equal. There we go. So I think a nice, easy warm-up question for us. Now I'd like you to take a look at b. So we're going to jump our way into b, and I think you can just end up making one really bad mistake. So let's address it right off the bat. You take a look at mine, and if your instinct is to, hey, I've got a 10 there and I got a 4 there, I just want you to notice that what I just crossed out, I can't do that. Those aren't factors. I'm dividing individual terms, and I can't do that because there was not a common factor of 4 in every term or a common factor of 10 in every term. So I think that's really your only really bad mistake. We're going to slowly kind of build up well, maybe not even slowly. We're going to build up an instinct that when we see multiplying fractions, we don't really want to multiply. Take a look on top. You're going to take a linear expression, degree 1, and multiply that by a quadratic expression, degree 2, Well, we should be pretty good to see that our next term, if we just multiplied, is going to be a 2x cubed. And then we're going to have the rest of that as we collect like terms. Well, do you know how to factor all your cubics? No, you do not. And so by multiplying, we actually may have just created a problem that we do not have the means to solve. So I want to make sure that our first instinct is not to multiply, but that it's to do what the problem said, simplify. So let's look and see, can we reduce each individual fraction, or can we do a little cross-reducing right off the bat? So in order to do that, that instinct I spoke about is going to get built pretty quickly. Our first step always should be to factor. Let's see what makes up those expressions. So what I'd like you to do is pause the video now. Let's factor everything and see if we can reduce. Okay, pause it. Okay, we're back. So I take a look at my first line. I can common factor out a 2 on top. Bottom is a simple trinomial. I can factor that. My next fraction is a simple trinomial, so I can factor that one as well. And on my bottom, I've got a difference of squares, so I can factor that. So notice, all my numerators, denominators could factor. Now I'm going to look to the inside. I'm going to see what makes them up. Is there anything I can reduce with? So I take a peek at that, and I notice I have a common factor of x minus 2 on top and bottom. I also notice that I have a common factor of x plus 2 on top or bottom. Now I'm really close on the other ones. I've got an x plus 5 and an x minus 5, but those aren't the same. What you see on your screen is the most dividing out that I can do. That is the most simplifying I can do. So what do we end up getting to? Well, that means that I'm going to have a 2 times an x plus 5 over, and on my denominator, I'm going to have my x minus 5 times x minus 2. Now, I know that the instruction says to simplify, but we're going to give you kind of an expectation, a pattern to be able to work through. I need you to know that if I tack on my restrictions on x, that is the best form for me to leave my answer in. I want to explain why. I want you to notice that, yes, I could expand the top and I could expand the bottom. So I could end up writing 2x plus 10 over x squared minus 7x plus 10. However, I want you to notice that that blue form isn't any more useful. Like if I asked you to go and do something with the blue, wouldn't you just have to refactor it anyway? So we don't expand unless we know that we can simplify our expression further. And I can tell in my last red line that there will be no more simplifying because there are no more common factors. So it's nice. We leave it in factored form. Okay, the only last thing to do, tack on those restrictions. I look back to my first factored form and I notice that my x value can't equal 5. It can't equal 2. But I also notice it can't equal negative 2. So I have my plus or minus 2. And by the time I look at that factor, I notice I already took care of that earlier. Nice. What you have in that final red line, there's our final expression. There's our final solution. Okay, hopefully that one wasn't too bad. You notice that really it comes down to how well do we factor. Once we factor, going on the hunt for common factors becomes a pretty straightforward process. Okay, let's keep it going for today. In order to do that, we just got to talk about a little bit of theory first. What I'd like you to get down in your notes is just a little heading, like almost a little title that just says restrictions. Because we need to have a discussion about what the restrictions are when we start to address multiplication and division expressions. So if we were to take a look at that first situation, I just have the most generic fraction multiplication question I could come up with. A over B times C over D. Notice I have two fractions, they're multiplied, and none of my tops or bottoms are equal. They're not the same thing. So that's what makes that as generic as could be. We should be okay that if you were to answer that question, you would tell me that that's equal to AC over BD, but that's not what we're talking about. So I want to make sure that we're good. We're not talking about how to calculate that. I would assume everybody could tell me it's AC over BD. But what we're talking about is the restrictions. So if I was to ask you, what restrictions do you have to put on that expression? I would hope that we would be good that B could not equal 0 because the first fraction would be undefined. And D could not equal 0 for the same reason. The second fraction would be undefined. Okay, hopefully not too bad. Now let's get down our restrictions for our division. So what I want you to do, jot down the restrictions that you think you need to include to make sure that the division expression is defined. Okay, pause it now. Okay, we're back. So hopefully we were good that our B does not equal 0 because the first fraction would be undefined. And we should have been good that our D does not equal 0 because the second fraction would be undefined. Now, I'm going to argue every single person should have the B does not equal 0. However, I may have had a few people that didn't have the D, that they might have put in that C could not equal 0 because you thought about how you would divide fractions. And you might have said, yeah, but I flip and multiply. So notice my C is on the bottom. So it wasn't D that was the issue, it was C. And so C shouldn't equal 0. And what we have to be very careful of is that we should actually have all three. So I want to go back and make sure that we also have good reasoning for why that's the case. Me flipping and multiplying has no bearing on it. Okay, the first thing, are we good that B cannot equal 0 because A over B has to be defined? So that bottom can't equal 0. There's our restriction. We should also be good that D cannot equal 0 because that denominator cannot be 0, or else the second fraction would be undefined. So how does the C not equal to 0 come into play? Just remember that what we're trying to avoid are divide by zeros. And I want you to notice that if that second fraction, the C value, equaled 0, well then 0 divided by anything, by D, gives me 0. And I want you to notice that's our troublesome issue. That if the C value is 0, then the whole second fraction's value is 0. And so I actually create a divide by 0. That's why we have that extra restriction on the end. It's not because of a flip and multiply. It's because there's actually 3 divide by operations in the second one. So let's look back at the original. Notice, there's my division, so I need to make sure I don't divide by 0. Restriction. There's my division, so let's make sure I don't divide by 0. Restriction. But you notice, there's a divide by, and there was an extra divide by in that expression. Okay, hopefully we understand how to find our restrictions. We've got that theory behind us. The rest of today, I just want to deal with some mechanics. So all we're going to end up doing is making some expressions a little uglier as we build. We should be good. Okay, what I'd like you to do is I would like you to go through, copy down expression in C, and then I'd like you to work your way through and simplify. I think we have enough to go through and tackle this on our own. Okay, pause it now. Okay, we're back. So this should just be a matter of confirming our factoring. And you'll notice that the speed at which you can factor is going to significantly affect how long each one of these problems takes us. But if over the years we've built up a good factoring base, we should be pretty quick. Okay, now we get to that point. We notice we have multiply in between, so now it's time to try to cross-reduce. I have an x minus 4. Those can divide out. Ooh, I have x plus 2s. Those can divide out. And I have x plus 3s. Those can divide out. So in terms of my solution, the only things that couldn't divide out because they didn't have common factors were my x plus 1 and my x minus 1. Nice. Okay, we're not going to forget about our restrictions. And so for us to go through and tack on our restrictions, we need to look at our first factored form. And so we're going to tack on that our x cannot equal -2, 1, 4, or -3. We don't care what order you write your restrictions in. They don't have to be in increasing order. Put them down in any order and you're good. Okay, hopefully that one wasn't too bad. Notice it was mainly about factoring. Okay, we're going to jump in and tackle another. Okay, you take a look at D and you notice that all that's happening is our expression is getting a little uglier as we go. Okay, I want you to tackle the same thing. So I want to go start to finish on this one. So pause the video now. Yeah, okay, we're back. So we're going to have a fair amount of factoring to go through here. So let's take a look at the first one. So two numbers that multiply to give 6, two numbers that multiply to give 1. I need a -5. So I have a 3y minus 1 and a 2y minus 1. Now, my advice to you earlier was try to use the factors that are present to go on the hunt to find other factors. Now, the problem with this is as we get more and more fractions or more expressions, it can be difficult to do that. So my focus to you would just be, you know what, just straight factor each individual expression, almost not even paying attention to the other expressions. So I now need two numbers that multiply to give 12, two numbers that multiply to give 2. If I do that, then there's a -8 and a +3. That can get me a -5. Now, I'm going to write something down, and I'm going to recommend that you don't do this. There's my divide by, and now I go to factor my next. Here's the reason why. Is that if we start to write down that other fraction and we're able to factor it, then we may start going, oh, okay, so now I can divide this out and I can divide this out, and then, oh, there's one of these here, one of these here. And we get so focused on the factors that we forget we have a division in between still. We can't divide out common factors, at least not across our fractions. So my suggestion to you would be don't factor it. Don't blindly copy down that division. I think what we could do is we could factor the second fraction and flip it to a multiply at the same time. So I'm going to look to factor the top of my second fraction. Two numbers that multiply to give 3, two numbers that multiply to give 1. I need a -4 in between. Now you can see my mistake, that I switched it to a multiply, but I didn't flip my fraction. You're going to find that with practice, you're not going to make that mistake. That you're going to be focused in saying, okay, so I'm factoring the top, I flipped it, so let's write those factors on the bottom. Okay, now I'm factoring the bottom. Two numbers to multiply. This becomes one of those ones where I know pretty quickly I can't use 2 and 2 because my middle term is odd. So I've got my 4 and my 1 and my 1, and a positive in both cases. That is me factoring the bottom, so when I flip it, I know it's got to go to the top. Okay, I get something like that, and now I'm on the hunt to try to divide out common factors. I've got a 4y plus 1 on top and bottom. I notice I have a 3y minus 1 on top and bottom. I don't have anything else in common. I know that I do not have to expand this because nothing is going to simplify after that, so I can leave everything in factored form. There we go. Okay, I know we didn't forget about our restrictions. And the weird part is, just take a look at your notes. Did you write x can't equal? Like we almost didn't pay attention to the fact that there are no x's in this expression? That really what we're talking about is y's? So make sure that we have y that can't equal. And we are scanning our way across the bottoms of my fraction. So my first factored form, that 4y plus 1 is going to give me a y value of negative 1/4 as a restriction. My 3y minus 2 means that y can't equal 2/3. My 3y minus 1 means that y can't equal 1/3. My y minus 1 means that y can't equal 1. And then we didn't make the mistake. Look back up to what that original expression was. It was a divide by. So that means that I also need to take into account the top, all parts of the second fraction. Okay, all parts of the divisor. So I'm fortunate, 4y plus 1, I've already taken into account that restriction. However, that would have been the restriction that we probably forgot. I noticed from that factor that y cannot equal negative 1, so I'm going to change that to a plus or minus 1 in my restrictions. There we go. Hopefully not too bad. So again, it's really just factoring. And then after we get really, really good at factoring, now we can divide out common factors. Okay, let's keep it going with another. So I'd like you to do the same. Let's copy down that problem. You give it a shot on your own. Let's use this one as a gauge. Are we comfortable with going through and dealing with multiplying or dividing our expressions? Okay, pause it now. Okay, we're back. And so, as I stated earlier, we should just be good to catch up with factoring. Two terms on top, I have a common factor of 3x, so I can factor that out. Two terms on the bottom, I have a common factor of 4, so I can factor that out. I'm going to change that to a multiply so I can cross-reduce as fast as possible. Now what that means is I'm going to factor the top, and I'm going to make sure that that top goes down to the bottom when I factor it. So I can common factor out a 9 and an x, and that leaves me with an x minus 2y. And now on the bottom, that will then become factored onto the top. I can common factor out a 3 and a y, and that leaves me with an x plus a 5y. Okay, I can go through now and I can divide out my common factors. Well, I've got an x minus 2y and an x minus 2y. I've got an x plus 5y and an x plus 5y. And then I've got all these coefficients. So a 3 will divide out of that 9 3 times. But then the 3 will divide out of that 3 once. And then I've got my x that divides out with an x. Wow, that's a lot of things crossed out. Hopefully we can see through all of that and notice that the only factor that's left on top was a y, and the only factor left on the bottom was a 4. There we go. Now we didn't forget about restrictions, so I'm looking on my denominator. 4 doesn't give me a restriction because 4 is constant, can't be made into a 0. However, that's going to give me a restriction that x cannot equal negative 5y. My 9 has no problem, but my x is there, so that tells me I need a restriction that x can't equal 0 as a constant. There's my x minus 2y, so that tells me that x cannot equal 2y. And because we were dividing, I've got to look at all parts of that divisor. The bracket there, I've already taken that into account. My 3 is not a problem, but maybe we can see through all of that mess that y that I'm boxing in. Oh, that would have been the one that we probably, and I need to mark that as a cannot equal. That y would have probably been the one that we missed. There we go. I think we're doing great. If we got down to that and we have that one perfect, I don't think there's going to be much that I could throw at you that will cause you problems. So let's leave you with one last one. It's going to look a little ugly when you look at it. It's not bad. Here we go. Yes, I understand that now I'm asking you to multiply and divide within a problem. So now we have 3 fractions, but I think you should be good for this one. So same thing, copy that down, full solution. We'll see if we match up. Pause the video now. Okay, we're back. So again, we're just confirming some factoring. Common factor of x, I have a trinomial. Difference of squares, common factor of x. I'm going to flip and multiply that one. So my top goes to the bottom. That's actually a perfect square. 2 numbers are multiplied to give 1 and add to give 2. My top actually is a perfect square as well. 2 numbers are multiplied to give 4 and add to give negative 4. Okay, everything is fully factored. Now I'm going through to try to divide out common factors. Well, I've got that single x and that single x. Those will divide out. I have an x minus 1, and on the bottom, I've got 2x minus 1s. So I can divide it out of there. I have a x plus 1 and an x plus 1. I also have another x minus 1 and an x minus 1. And now I look, well, my x minus 2s, I've got a bunch of those. So I've got my x minus 2, another x minus 2 that will divide out with both of those x minus 2s. I got everything that all divided out. So I'm left with 0, nothing left. Okay, I'm hoping that you just caught that error. Remember, when things divide out, we're left with 1 because we're dividing something by itself. Hopefully you got down to 1 as your final solution. Now we just got to knock out all of our restrictions. So we've got x cannot equal, and I'm just going to work left to right, taking into account all parts of any divisors. X can't equal 2, negative 1, 0, 2, 1, and on top, 2 again. There we go. I can get rid of that comma at the very end, and we have every restriction included. Nice. Okay, I think that all you're missing now is just getting some practice and trying to drill this in to the point where you almost don't even have to think about it. That it just becomes a mechanical process for us to be able to go through and simplify. Okay, jump into your practice. Best of luck.